I don't know how this would go in this class. I really don't, because there's nobody that's like super duper tall or short. But if I said, hey, let's find out who the tallest person in the room is. Hold on. If I said, let's figure this out. Let's figure out who the tallest person in the room is. Well, it's probably Cole, isn't it? I bet you it's Cole. What would be your process? If I said, let's figure it out, what would you say? Everybody stand up. Everybody would stand up, and then we'd need to like maybe measure on the wall and have all these marks on the wall or something. And eventually we'd be like, well, you know, we got Mr. Anderson and somebody and somebody and somebody, and then maybe Cole would be up there somewhere. And we'd be like, hey, I see it. It's the highest mark. And like there'd be no arguing about it. There'd be no confusion. It'd be like, that's the highest one. And we say, well, who's the shortest? And we'd be like, well, okay, well, there's the lowest mark, and that must be the shortest person. That's kind of what we're doing here when we do these absolute extreme questions. We're basically saying, I want to figure out what the highest point is, and I want to figure out what the lowest point is. And once you figure that out, it's really straightforward. You're like, there it is, right? So when we take a look at example number 1, it says, no calculator, find the absolute min and max of f of x. And if we're looking for these absolute extremas, like this is asking us, it's always going to give us some kind of a boundary, some kind of a domain with which we need to work with. So it tells us on the interval -1 to 3. So if you remember from last year, or you remember from the video, either way, what are the candidates for absolute mins and maxes? Critical points and endpoints. You have to consider endpoints and critical points. If there are no endpoints to consider, then it's either kind of like a poorly worded question, or there might be some more like mathematical magic stuff we got to do. But I'd say the vast majority of the time, we're going to get some endpoints. So, since you mentioned critical numbers and endpoints, where do critical numbers come from? F prime equals 0, or does not exist. So if we're going to find where f prime is 0, or doesn't exist, we should probably figure out if we have f prime. Do we have f prime? I don't. But we could probably find it though, right? So sometimes you're going to get f prime. Sometimes it's just going to be supplied to you. Other times we're going to have to find it. This is one of those cases where we got to find it. So f prime of x equals, a little practice here. Everybody think they can do power rule a couple times? What do you think? F prime equals? 2. X to the what? -1/3. Agreed. Okay, so Emma earlier mentioned that critical points come from where f prime is 0 or does not exist. I always will mentally do a quick check on the does not exist. So are there any x values on our interval here in which f prime does not exist? Negative numbers? What's wrong with negative numbers?
Oh, no, actually, it's the cube root.
Cube root, yeah, you can do the cube root of a negative. Are there any x values in which f prime doesn't exist? 0. Who said 0? 0. What's wrong with 0? Isn't this a denominator right here? Negative exponent really means denominator. And so, yeah, I totally agree with you that one of our first critical point is going to be when x equals 0, because when x equals 0, f prime has a 0 in the denominator, therefore doesn't exist. Agreed. We also have to consider when f prime is 0. So I'm going to write 0 equals. This is kind of an important point to bring up here. Anytime you set something equal to 0, like with an equation like this, it is hyper important that you write it down. Don't just think it. Don't just say it in your head. Don't just type it in your calculator or whatever it might be. Write it down. If you said f equal to 0, f prime equal to 0, y double prime equal to 0, or whatever it is you're setting equal to 0, write it down. Any ideas on how to solve something like this? Come on, the video has some blank airspace here. What's that? Do a t-chart. I just want to solve for x. We will do a table in a little bit. I agree totally. But we need to find our critical points. Like we got our endpoints; they're obvious. We found a critical number, which is 0. We got to find if there are other critical numbers. Find out where there are other places where we got a horizontal tangent line where f prime equals 0. So my question is, how do you solve for x? What might be a good first step? Okay. And while we're doing that, can we just divide by a negative?
Yeah.
And just say 2 equals 2x to the negative 1/3? You guys are just kicking the can down the road a little bit. What might be your next step? Divide by 2. Okay. So that gives us 1 equals x to the negative 1/3. Say again?
May or may not be 1.
So will somebody please deal with the x to the negative 1/3? That's what you keep avoiding.
That's 1 over.
Okay, so 1 over, sure. 1 over cube root of x. Fair enough. I'll keep going. What could you do now? Multiply by what? Yeah. Mr. Blake was totally wrong, Jake. You do belong. Because you are the one that's actually keeping this boat moving forward right now. Everybody else is just like, what? He keeps coming up with some good ideas. Johnny's with me too, I think.
Mr. Anderson,
Yes.
is 1 to any exponent going to be 1?
Is 1 to any exponent going to be 1 as long as the exponent you're talking about is a real number? Yes.
So since we've got 1 equals some number times an or some number to an exponent, we know that any number, or that 1 to any exponent is going to be 1.
Sure. So therefore x equals
1.
1. Yeah, agreed. I was just looking for some steps or some good reasoning, and that was some good reasoning. What I wasn't looking for was blank silence. That was well done. Well said. All right. So now we're going to get it back around to what Johnny suggested a moment ago. And that is, we're going to make a little table. So our inputs are going to be x's. Those are going to be our candidates. Our candidates are going to be our endpoints and our critical numbers. Bless you. And am I going to take these candidates and am I going to plug them back into F prime or am I going to plug them back into F? Yeah, because we're basically trying to see who is tallest, right? And who is shortest. So we want to compare the values of F when we're doing this. So let's see, if you plug in a -1, what's the output? What's F of -1? Well, let's see here. It's -2. What's -1 to the 2/3? It's 1, right? So F of -1 would end up being? -5, I think. Let's do an easy one. How about 0? 0. How about when x is 1? Gosh, I put no calculator here, but 3, I don't know. Might be nice to have a calculator. I guess it would be 6 minus 3 times the cube root of 9. I don't know. What's that on a calculator? Anybody have a calculator out? Throw that in there real quick. Negative what? Negative point. Let's go 3 decimals just out of respect for what we got to do. 240. Okay. Sounds good. All right. You guys getting the same thing as Dylan?
Yep.
Okay. Awesome. So now it's judgment time. We're looking for the max and the min. What numbers am I looking at to decide, yep, that's the highest or that's the lowest or whatever? The y values. You're right. So we can say the max is what? 0. Yep, max is 0. So we're looking for the highest y value, and they're all negative except for the 0 on the outputs, right? And the min would then have to be? Negative what? I think -5.
Oh, that's what I meant. I meant the x.
You misspelled negative. Oh, when x is -1. That's actually a great point. When all it asks for is what's the max and what's the min, they're definitely asking for a y coordinate. If they say where is the max and where's the min, that's a little more confusing because it's like, are you talking about an x comma y? Are you talking about an x or a y? But if they say what's the max,
I was just saying
find the max. Yeah, you know the safest way to go that'll probably get you there 99% of the time, just put x comma y.
Yeah.
At the reading, I think they pretty much always take that, although I think there was some debate about that this year. So anyway, question, Johnny.
Question. It's kind of to do with this along with the video we watched today. So whenever there's a hole at the end of the equation, like if it's
If the interval is not fully closed?
yeah, like the very last example you gave on the,
Yep.
on the video, could the absolute max or absolute minimum be a limit to do that, or would that not?
No, because so the max and min is going to be an actual point on the graph. And a limit is not a point on the graph. A limit is that pattern of behavior. I get what you're trying to say is like, well, what if we got really, really close? If we got a little bit closer and a little bit closer? My question back to you would be, well, exactly how close could you get? Or that's the hard thing, to just be like, well, I'm as close as I can get. Well, I could get closer. And then you could say, well, I can get closer, and we'd both be right. And then Alexandra could come in and be like, well, I'm the closest, and she'd be wrong because then somebody else could get closer. So that's what that EVT is talking about, simply saying for you to actually guarantee that you have an absolute extrema, you got to have a closed interval and continuity on that closed interval. So yeah, it's a good question though, right? Because you just keep closer and closer. How close could you get? Okay, cool. Any other questions? So it would be okay, is as you hear me and Johnny talk about this video and the extreme value theorem, if you're just like, good Lord, what are they talking about? It would be okay for you to go back and watch the intro video after class. It'd be okay to do that. So consider. All right, let's do another one. Let's take a look at number 2. This is definitely calculator active. This would be a nightmare without it. So it says a particle moves along the x-axis. So it's just moving left and right, back and forth, back and forth, back and forth. So that its position at some time t is given by that x of t function right there. And it says, so position being distance from the origin. During time interval closed on 0 and 10, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. So what is a key word in here that tells you this is what you got to do? Say again? Greatest. So what is greatest really talking about? Max. You are correct. So we're looking for the max distance between the particle and the origin. Let me just remind you that maximums are going to happen either at endpoints or critical numbers. Could go either way. And the endpoints are right there, 0 and 10. And so really your big task with this would be to find some critical points and then try to use those to determine what the max is. So I'm going to give you guys a moment or two here to try this by yourselves or maybe with a partner or something. Remember the calculator is active. That will give you a significant advantage on the mechanics of this. Just make sure you write stuff down. But I'll give you a couple minutes to work it out, and then we'll check some answers in a second. If you haven't already started, ready to go. Let me see if I can catch up to you guys. As far as x prime goes, that's where we're going to be finding our critical points. X prime is equal to negative 3t squared plus 16t plus 4 pi cosine of pi t. So take a look at your x prime, take a look at mine. Let's make sure we agree. You guys have any questions on that? You see the chain rule there on the last term? Good. So critical points come from where x prime equals 0. So guys, I want to be really clear about this. If you're smart, you used your calculator to do this. But make sure you write this. You watching? Equals 0. Without writing that, there's really no equation to be solved. So what I would do is I would take that equation and I would solve it using my calculator on the interval that I was given there from 0 to 10. How many critical points showed up on that 0 to 10 interval? 3? 4? Oh, man. Let's get some consensus on this. It's been about 12 months since I've done this question, so I don't remember. You see 3?
Well, for...
I'm just looking at the interval 0 to 10. I don't care about outside that.
Okay, and you're talking about where the derivative equals 0, right?
Right.
I think it's 3. Yeah. Pretty sure, because it bounces at one point, but that wouldn't be an absolute max.
Are you sure it bounces and doesn't cross over barely? I just don't know.
I'm not sure.
Oh, okay, so it just like stops short?
Yeah.
It almost looks like it bounces? Okay. So let's hear it. Did you guys figure out what these critical points are? T equals 4.736, Johnny says. What's another one? If there are three of them.
5.631.
5.631. 6.026. So do you guys agree with those 3 points? Just using our calculator to solve that x prime equals 0 equation. Oh, definitely want to be in radian mode. I forgot to mention that, Jake. Yeah. Radian mode. We're always in radian mode in here. Okay. So at this point, I've got 3 critical numbers and 2 endpoints. I'm going to make a table, and I think I'll go horizontal this time because I'm out of room. So I'm going to have my 3 candidates, which are, or my 5 candidates, 0, 4.736, 5.631, 6.026, and 10. Got my 5 candidates. I'm going to be plugging those in for the input on X, and I'll be getting some outputs. So, gosh, when t is 0, it looks like -7. The rest of them, I don't know so much. So, some suggestions. What about when t is 4.736? 191. Okay. How about the 5.631?
64.451.
Just shout out if you disagree with any of these. 6.026
65.008.
and 10.
-207.
Whoa, is that really right? It like totally drops off, doesn't it? Crazy. Very interesting. Okay, so we're looking for, this is where this one gets a touch tricky. You guys paying attention? Notice it says, go back to the question, it says, what is the maximum distance between the particle and the origin? What would you say is the max distance? So distance is actually scalar. It does not have a sign with it. So it's true that when t is 10, isn't the particle way to the left of the origin? But that distance, we would express distance as always a positive number. So I would say the max distance is 207. So this is a little bit of a tricky one simply because we look at that -207 and say, well, that's the lowest number. It is the lowest number, but it is the greatest distance because we're talking about distance, not location. Okay. We good? Fantastic.
I had a question.
Sir.
So why wouldn't you find the actual like distance, not just from like the x-axis down, like actually?
So we're moving left and right, not up and down.
Oh, sorry. But why wouldn't you calculate the distance between the origin, not just the axis? Like you do.
We are calculating, that is the distance. The way this is defined, it says here that x of t is defined as the position or distance from the origin between the particle and the origin. So yeah, like what Cole just said is the particle is moving left and right. So t is just the time, and x of t is literally the position.
I
So
understand.
yeah, so like literally if this is your x-axis, the particle is just going, you know, well, let's see here. When t was 0, it started at -7. So here's position 0. Here's position -7. And it clearly goes over here and kind of does this a little bit. And then at the end, it goes way over there.
Oh, I understand. Okay.
And so we're looking at this and we're saying, well, that's position -207. That's the furthest it is from the origin on our interval.
Yeah, that makes sense.
Okay. Thank you for asking, Dylan. Appreciate that. Anybody else? Jeff, yeah.
So is that the right equation
For what?
for the
For the derivative?
yeah?
Should be -3x squared plus 16x plus 4 pi cosine of pi x. Yes, sir. What mode are you in?
Radian.
Okay, agreed. So what's your question?
So like the graph doesn't match.
So that's the, okay, so what you were graphing there is the derivative. My graph right there is the position. So you graphed velocity, I graphed position. They're two different things. They won't match up. So the particle's just going back and forth, back and forth. The velocity is going up and down and all around. Does that make sense?
So how can we get the graph? for position?
You would graph this. What's going to be hard to see, this is a lot deeper, maybe, than what you're thinking. What you would see, you would still see one of these graphs, but the y would represent distance horizontally, and the x would represent t. I could graph this for you. I can't do it. I'm not going to do it right now because I want to get to one more thing. I could graph this for you in a calculator, and you could actually see the back and forth, back and forth. There's some really good connections made. If you want to drop by, you have to show that to you. Okay. Yeah. No problem. Hey, we may or may not get to number 3. If we don't, we'll just do it as a warm-up tomorrow. I wanted to do a little get-to-know-you thing. I do this every year, and so if you've had me before, this is really similar to what we've done before. I do these little 3x5 cards, simply because they're easy for me to keep track of, and I get these out from time to time, and it's just good for me to get to know you a little bit.